All right. So today, basically, we want to look at measurement of construction works one. Yes, we want to look at measurement of construction works one. Exactly. All right. Measurement of construction work is the process of quantifying and describing construction works activities like excavation, concrete block work finishes, etc. In standardized unit to prepare bill of quantity, estimate cost, and it ensure clarity in project documentation. Also, it is a systematic process of quantifying construction tasks. An example is length, area, volume, or width, or even number, and recording them in a clear standard format. Okay. The purpose of measurement of construction work is to ensure transparency. The purpose of measurement of construction work is to ensure transparency, consistency, accuracy in cost estimation, and also tendering and what? Project management. How did I say construction? Or how did I say measurement of construction work is? We said measurement of construction work is the process of quantifying and describing construction activities in standardized unit to prepare bill of quantity, estimate cost, and ensure clarity in project management. Exactly. But if you say construction activities, an example of a construction activity could be excavation, concrete, brickwork, and finishes, etc., etc., etc. Good. The standard units that, or let me say, the standards that are using SMM7 or measurement of construction work are one, the SMM7, okay, and that is the standard method of measurement. We have SMM1, SMM2, SMM3. You see, if SMM2, SMM3, SMM4 means they are all additions. Okay, so we consider we are on edition 7 now. Very soon we are going to have edition 8 and edition 7 is going to be out of the system. But for now, it's SMM7 that we have all accepted that we are using now. Okay, so basically very soon we are all going to learn how to open that. Basically, this is an example of the SMM7, okay? And that is what we are going to be using to do all our calculations and all that. Yeah, so maybe you who have not seen SMM7, this is how it look like. Okay, yes, this is how the SMM7 looks like. Thank you. So the SMM7 is widely used in the UK for building projects. Okay, and also we have the new rule of measurement. That is, it was developed by the RICS, covering cost estimation, detail measurement, and maintenance work. Okay, yes. And also for the BESMM4, that is Building and Engineering Standard Method of Measurement. It is adapted in Nigeria and is similar to NRM2. Yes. Okay. Let's look at some basic key principle in measurement of construction work. One, we have objectivity. Objectivity simply means quantities must be verifiable and measurable. Yes, your quantity must be verifiable and what? Measurable. I believe this is self-explanatory. And also you must be consistency. There is a difference between punctuality and consistency. Okay. Yes, so that means that the standard method of or the SMM7 should be used more frequently. Okay, if you don't practice, you will never become perfect. Once upon a time, I was facing much challenges with measurement of construction work. Today now, I'm teaching measurement of construction work, and it is as a result of what? Constant practice. Yes, if you fail to practice, you're going to face a lot of challenges. Good students at this point should take a pen and a paper so that once I make reference to some important point, they can be able to what? Jot down some one or two things. All right. And also one of the key principle in measurement of construction work is also that we do documentation. That is what we keep record of references and also the scale of drawings, okay, and convention factor and also running methods. There is also transparency. Okay, that is you have to be clear in your description to prevent dispute and overruns. Yes, to prevent dispute and overruns. If we say something is a dispute, something that tries to bring a misunderstanding, okay, and that is an example of a dispute. All right. Okay, so these are some examples. These are some examples of measurements in practice. Okay, yes. So as you can see, this is a table over here I have been able to develop for you to able to be enhanced, to be able to enhance your understanding. Yes, and you can see we have the excavation. Excavation work is measured in what? Meter cube. So you have to jot down somewhere if you're going to take a screenshot, anything that is just going to help you to be able to what remember in future. Okay, yes. So excavation works are measured in meter cube. Concrete works are also measured in meter cube. As simple as that. And an example of the excavation I'm talking about is the digging of what? 200 meter cube of soil. Yes. Take note, if we say area of excavation is different from volume of excavation. If you hear somewhere they say area, they normally use that in estimation. Because I'm also teaching you construction estimation, that is why I'm taking time to explain this better. If we say area of what? Excavation, that one is measured in what? Once you heard area, it is supposed to be what? Meter squared. But if you hear volume first, volume of excavation, then that one becomes what? Meter cube. Good. All right. So I believe at this point I can clean the board. We are good to proceed. We are good to proceed. If you have any question, you can type it in the comment section, and or you could write them down when you see me in groups, in person, one-on-one. You can ask them and I'll give you more explanations to that. Also, don't forget to like the video, subscribe to my channel, and also like and share for more. Take note that brickwork is also measured in square meter. Okay, and an example is a 120 meter square of wall surface. Yes. Roof works are also done in meter squared, and also doors and windows are done in what? Are measured in numbers. So who are the meter cubes over here? The concrete. Take note today. Concrete is measured in meter cube, and excavation is also what? Measured in what? Meter cube. Exactly. Exactly. Why does SMM7, or let me say, why is measurement of construction work? Why does it even matter? One, it helps in cost control. Okay, that it helps us to know the accurate measurements, ensure to realistic what budget. It also helps us in tendering. That is, contractors can provide works fairly. Okay, that is, it provide a standard method of even pricing, so that at the end of the day we all can price on the same thing. And also for project management, it helps progress and what? Variation. It helps progress and variation. That is, you're able to track the progress of the or the ongoing of the project, and also uncertainties or differences that comes with that. It also helps to avoid disputes. That is, the standard method of measurement reduce misinterpretation. Someone can say, oh, Blockwork is measured in meter cube. Someone is saying it's measured in meter square. If that is the case, then let's go and check from the SMM7. If you go and check to true, you see that no, the blockwork is measured in what? Meter squared. And it's rather excavation that is measured in what? Meter cube. Good. What are some challenges that are in measurement of construction work? One, there is ambiguity. If we say ambiguity, that means poor description and can lead to dispute. When we say something is dispute, we be ultimately akatakasa bebreba. Okay. Also, inconsistency. One challenge is that using different standards across projects makes comparison difficult, because at the end of the Nigeria is using a different one, Ghana is also using a different one. If they come here to build, you realize that they are going to use a different one. We also use a different one. It ends up resulting in a whole lot of things. So if we all can be able to accept one thing, then you realize that life can be much more easier. Okay, it also helps. One challenge is that there is also overrun. That is, mismanagement often results in cost or time overrun. Okay, that is, if you don't manage well, at the end of the day, we book and I say, "Oh, time now, would you manage crano?" It's going to affect you greatly or also largely. Good. Measurement of construction work evolved gradually from ancient practice of measurement and valuing project works. The modern profession of quantity surveying, which formalized measurement method, which formalized measurement method can be tracked back to ancient Egypt, where officials called measurements of royal works, that is quantified material for pyramid and temples, and later to 17th century Britain, especially after the Great Fire of London in 1666, when rebuilding required systematic cost control. The first formal appointment resembling today quantity survey was John in 1688, who was sworn in as the ordinary measure for Edinburgh. His historical development of measurements in construction. Let's look at some historical development of measurements in construction. One, in ancient civilization, Egyptians had officials who measured some stone blocks and construction work for pyramids. Also, in building of the Roman, I told you that in estimation, surveyors and engineers, or let me say, Roman used surveyors and engineers to measure road, aqueduct, and public building. I showed you the aqueduct in hot estimation. Those who watch the video would have appreciated that much. And also, it was also used in hot. The idea of measurement of construction work. It was also used in public buildings. Okay, so you can see this idea has been there not today. Okay, so once someone has been able to do it, it means that we can also be able to do it. Okay, yes, you can also be able to do it. All right. So let's proceed. In summary, measurement of construction work is the backbone of cost management and project clarity. It transforms drawing and specification into quantifiable data, ensuring all stakeholders share a common understanding of scope, cost, and progress. Good. So basically, these are some abbreviations in measurement of construction works. Okay, basically these are some abbreviations in measurement of construction work. You can see the meter over here, meter squared. You can see these are some abbreviations we are going to be using. So once you see them, you should know that, oh, this is their name. Okay, okay. So you can see I'll be using some of these things more. These ones I'll be using them more. So you see the foundation, you see how they are fitting. If they write FD N dot, it means foundation. Excavation, so you see how they fit in it. Good. The block work. The Blockwork, see how they have written them. These are some of the ones you are going to be seeing more often. Yes. So that is it. That is it. The glazing, so you can see how it has been written. Look at wood. When you write a short form, even for diameter, strength of material, you will meet it. That is when you get to form 3, theory and design of structures, you will meet it over there. Okay. Yes. So these are just symbols. You have to keep this on your phone. Take a screenshot, make it favorite, play with it more. The more you look at it, the more it's sticking in your brain, so that before the exams, you don't face much challenges, or when you're in the exam hall, life can be much more easier. I have a trial work over here. I wish we could all practice. This was mid-sem last year, mid-sem question, and then I don't know, but it came in the exams also. Let's try that over here. It's just a trial. It doesn't mean it will be coming. Yes. And see how best life can become much more easier. So the question says, take off for foundation works, which is of a cavity construction. Okay. So this is the question, and you can see drawing number 1. Yes, and this is the drawing number 2, and this is the drawing number 3. Let's look at what our specification entails. Yes, even before we move to our takeoff sheet and then proceed with the work. So under our specification, we said that what we have topsoil to be retained on site 20 mm from excavation. All right, let me see if I can share two screens to make life much more easier. All right, so I think this is a bit dynamic. Okay, so let's read the specification. You can zoom the screen so that you see it well. So we have drawing number one. That is drawing number one. Drawing number one. That is details the foundation work which is of cavity construction. The specification notes include topsoil excavation to be retained on site from excavation. Also, section 2 says foundation concrete to be of institute concrete design mix C25 20 aggregate minimum, cement content 290 kilo per meter cube of volumetric mix 1:3:6, 20 aggregate, 20 aggregate. Good. Also, I can see a block work 102.50 block work of I can see a block work of 102.50 thick brick wall in cavity construction in common brick and stretcher bond and cement mortar. Cavity formation 50 wide between skin of brick and fill with weak concrete 1:6 to within 150 of damp-proof course level. Hardcore 200 thick, well compacted and blended with sand. Also, we have damp-proof membrane of 100,000 gauge polythene. Concrete bed to be of institute concrete design mix C20 of 20 aggregate. Minimum cement content should be 240 kg per meter cube. And damp-proof course is Hassan base bitumen felt of BS 743. So these are the specifications they are giving you. The specifications play a vital role. The specifications play a vital role. Okay, so you don't have to joke with the specification too. We are saying that specification writing is the process of creating detailed documents. Or let me say, okay, let's forget that. Let's proceed. All right. So I'm just this. So this is our plan. Okay, this is our plan, and this you can see that I've written over here. Drawing number two. You have to pay attention to some of these things. They have written over here. Drawing number two. So where is our drawing number one? That one was on the specification. Yeah, I have to, that one we can only see it in the main question. Yes, this is it over here. You can see that this one is drawing number one. Good. So who else again? So I'm thinking the cross section is going to be our drawing number three. Once we stipulate it on it, then we know that we are on the right path, right? Okay. So this is our drawing number three. All right. So we have to proceed, and then we have to move to our takeoff sheet. This is my takeoff sheet. Yes, forgive my takeoff sheet if it's not beautiful, but I had to be creative enough to be able to make the initiative a solid one. Yes, so spare me for that. All right, so let's proceed. So if you have a work like this, and then the question says that what? Take off for foundation works. How are you supposed to go about it? Take note. In your midterm, you may be asked to just take off for excavation of topsoil and earthwork support. Or you can be asked to do block work and surface treatment. They can give you any two or three. Okay, but I will advise you that uh, being just understand the concept I'm coming to give you now, understand the game I'm coming to give you now, and life is going to be much more easier for you. Let the message enter into you so that in future, even when you are asleep and someone wake you up, you can also be able to teach someone. Exactly. All right. So if you have a sheet like this, what is the first thing you're supposed to do? The first thing you're supposed to do is you are supposed to cut 6 lines. Take note that in measurement of construction work, you are free to use different color pens. Okay, it is accepted. You can use different color pen to make your work more dynamic and also to direct the examiner. Okay, yes, to direct the examiner because using different colors also gives visual meanings. Yes. So we have to cut 6 lines. This is the meaning of that. One, two, three, 4, 5. Then we add the last one, 6. So you see that we are done. Yes, exactly. So the first one, we are going to put the project title on it. Okay. So in the exam, so don't write project title, but I have to write the name of the project on it. Yes. So let's proceed. So this is going to be our project title. So here is going to be our project title. Can anyone tell me what he or she think the title is going to be? Project title. For learning purposes, let me maintain it like this, so that no one go and repeat that in the examination hall. So the project title, you put the name over there, okay? And the next thing you come and enter in this column is the what? Is the date. Yes, you also add a date. Good. And then the drawing scale. Which scale was given us which scale uh was given on the drawing? Let's move to the specification. If there is no any scale, then we just only write not drawn to scale. Okay. Yes, but it's a choice. That is, it is up to you. So in the examination hall, you have to be able to what? Put that down. So in this column, you're going to write drawing scale. If it's 1:50, 1:100, whatever it is, you put it inside. Okay. So this is the drawing scale. Good. After the drawing scale, what are you going to put over there? Which standard of method are you using? Which standard of method of measurement are you using? Is it SMM5, SMM6, or which one? So you put it over the the one we are using is SMM7. SMM7. Nicely. And what do we do next? The next thing we do is the drawing number. Okay. So the drawing number is, let's say, the drawing number is drawing number 2. Okay, on the plan. Okay. Our drawing number is drawing number 2 from the plan. So let's quickly go and put that there. So we say that this is our drawing number 002. Drawing number 2. Okay. Then the last one is going to be our takeoff list. Then the last one is going to be our takeoff list. So this is the meaning of these 6 lines I say you should cut. Okay. For the last one, it's a very serious one. So this is your takeoff list. You're supposed to put it down. Take note, all these things they give marks. The project title, the date, the drawing scale, and the SMM7, and even the drawing number you write. You get marks for that. So you can never get 0 in SMM7. If you score 0, I'll blame you. Yes. Okay. So we write over here take off list. So this become our take off list. Okay. And then the take off list, we are going to list all what we are going to be doing the take off for. I mean all what we are going to be doing calculations for. Okay. Yes. Those are the things I'm going to list in my take off. So first of all, if they say we should do what? Foundation work for this plan as we are seeing over here. If they say we should take off for foundation work, which is of cavity construction of this, First of all, you realize that we have to start from excavation of topsoil. Okay. Yes. Or even that, we have to what? Clear the site. Okay. But let's say that the site is already cleared and all that, and you're just coming to begin. What are you supposed to do? You're supposed to start with the excavation of what? Topsoil. Yes, excavation of the topsoil. So let's move to our SMM7, or let's move to our takeoff sheet and then we list them. Okay. So this become our one. So I'm going to write that. So the first one is going to be excavation of topsoil. Excavation of topsoil. So the first one we are going to do excavation of topsoil. Or better still, let's start with what? First of all, we have to clear the site. Yes. So, but let's forget. So let's do excavation of topsoil. Excavation. I could have written the shortcut, but I just spared you. So excavation of topsoil. Then in our next step, what are we supposed to do? After we excavate topsoil, we have to do disposable of excavated waste. Okay. Yes. So after we are done with this, we have to come and do disposable of excavated waste. Disposal of excavated waste. Okay. So this is going to be disposal of excavated waste. Disposal of excavated. I showed you the shortcut. So disposal of excavated waste. If I write it that way, you don't get confused, right? Excavation is written as a shortcut of this. Look at from this drawing. You see how they've written excavation. This is it over here. That is the shortcut of it. Thank you very much. Let's proceed. So disposal of excavated waste. And also the next thing we do after the disposal of the we have to do what something we call the surface treatment. That is when we talk about surface treatment, it just entails the compaction, the filling, and all the rest. Okay. Yes, those petty things we do are part of the surface treatment. So the next thing I'm supposed to do is the surface treatment. So the surface treatment, the surface treatment. Then after the surface treatment, it's usually done at the foundation bottom. Okay. So the surface treatment there is always done at the foundation bottom. And also after the surface treatment, what are we supposed to do? We are supposed to do disposal of surface water. Okay, that is if there is any water coming, if there is any water coming from the ground and all that, we are supposed to find some ways and means to uh clear that. Okay, yes. So this is the surface treatment. Bear in mind that is mainly for the foundation bottom. You see the way I've written the foundation again. Don't get confused because I showed you the shortcuts. You see how they've written foundation also over here. All is a matter of shortcuts. And these are the languages of measurement of construction works. Yes. At the end of the day, we are going to be becoming quantity surveyors. And this is our main subject. Okay, this is what we are going to be doing after school. So if you don't make this part of you, you are going to face challenges. Okay. So just find a way to understand it to make life much more easier. After that, we are going to do disposal of surface water. So disposal of surface water to disposal of surface water. Then probably our next thing we are going to do is concrete in the foundation. Okay. So you have to come and do the concrete in the foundation. So we're going to do concrete in foundation. Concrete in foundation. And that is our step 4, or let me say that is rather our 5th. So the 6th takeoff we are going to be doing is after concrete in foundation, hotness. After concrete in foundation, we have to do block work. We have to do a block work. Okay. So we have to do block work. Then after the block work, we also have to come and do a hardcore filling. You see, it's just like I'm teaching you how to build. These are the processes involved in building. If someone give you land to build right now, these are some of the things you're supposed to even do, even before you start with the main work. Okay. So these are the hard core filling. Okay. So after the block work, we have to do hardcore filling. Then we'll come and do a surface treatment again. We have to come and do further compaction again. Okay, for the floor and all that. So let me put it over there. This is 8. And then we come to the 9th one. All right. So the 8th one become our surface treatment. We're going to do surface treatment again. So we have to do surface treatment. And then from there we are going to be doing the form works. Okay. After the form work, before the concrete work is going to come, then we can say that we are done with the foundation. So after the form work, then let's say concrete work can take off. Concrete work can begin. That is the oversight concrete. Yes. So you see how things are moving. Yes. So at the end of the day, how many steps did you go through? First of all, we say you have to cut 6 lines. Yes. First one, you write the project title, you write the date, drawing scale, the SMM7 you are using, the drawing number. You are done with that. Then you come to your hot takeoff list. In the takeoff list, you are going to be listing all the things you are going to be doing the calculation on. If they say foundation works, they didn't. If they have said take off for earthwork support and also the earthwork support is the same as the surface treatment, and don't get confused. So if they had said that take off for earthwork support or surface treatment and block work, you know that it's just the two you are going to do. But this one they said foundation works. It means that it's cover for all. Yes. So bear in mind you can be asked to calculate any two of this and just grab the understanding so that on the day of making account for what you have been taught, uh, you wouldn't disgrace me. All right. All right. So let's proceed. Let's proceed. Okay. Because my sheet over here is not enough. Um, so I want to come down and come and continue the next section from here. Okay. Mm, my sheet is not too enough, so I don't know if I don't do it that way. It wouldn't help me too much. But I can only do this. Okay. So that we see how best we can be able to travel. Okay. So just a minute, okay? Just a minute and we'll proceed. All right. Okay. So now I think we can continue. Okay. Yes, we can continue. So from here, what is the first uh measurement of in our takeoff list? What is the first thing we put? The first thing we place over here is the excavation of the topsoil. Okay. Excavation of topsoil. So that is the first thing we have to list. Since that is the first thing we're going to be doing our calculation on. Yes, that is the first thing we have to list. Since that is the first thing we are going to be doing our calculation on. Okay, so good. 1T. All right. So we have to list this over here. And this is let me say 1. Okay. And the one we are first of all we want to start with, let's say topsoil calculation. Okay. So let me write here nicely. Topsoil excavation. This is our topsoil excavation. Topsoil excavation. Good. So in the topsoil excavation, how do we go about it? In the topsoil excavation, one may ask, how do we go about that? It's as simple as that. Okay. Yes, it's as simple as that. So the first thing we are supposed to do is that what is the width of the foundation? We have to know the width of the foundation. And if you go to, let me say, the plan we are having here, or even the cross section, you realize that the width is just from here to here. This is the width. This is the width of the foundation. That is the width. So the width is what? 750. Okay, good. So let me quickly move to my takeoff sheet and then let's proceed. My weight is 750. So the weight is 750. So let me say this is the foundation weight. So FDN. That is the shortcut FDN width. So that is the foundation width is 750. So we have to what? Less. Less means subtract. Okay, so if you hear it somewhere, that is the meaning. Then we have to less 225 from it. I hope you know what the 225 is. Yes, I'll show you now. And the 225, if we come to the cross section, the 225 is actually from this. This is the 225 over here. Okay, this dimension over here. Yes, this is the dimension of the 225. And you have to take note also that this block work over here, it also has a dimension of what? 225. So don't make these two things confuse you. Okay. The thickness of the concrete is 225. And then the block wall, the thickness of the block wall cavity is also 225. Okay. But which 225 are we supposed to use here? Or which one are we subtracting from the 750? At the end of the day, they only want to know the spread. They want to know the distance from here to here. And also the distance from here to here. Okay, that is all what we are investigating. These two distance, 1, 2. So this is the 1, this is the 2. So these are the distance really, and these are the spreads. Okay, so what are we supposed to do? This 750, we are supposed to subtract the 225 from it. Okay, yes. So let's see how we do that, and then at the end of the day, we see how to come and get this answer. Okay, all right. So 750 minus 225, we are going to get 495. We are going to get 495. And this 495 you are going to get over here, you realize that the foundation spread is 2. Okay, if I go to the cross section now, you see the foundation spread is 2. There is 1 over here, there is also what? 1 over here. So when I subtract the 490, when I subtract the 225 from the 750, you realize I had 490. So the 490, I have to divide it by 2 so that I can get the spread for one side and then I can get the spread for the second side also. Okay, good. So that is how it is like. And then watch. Look at how I'm going to do it. The less here is a different symbol on its own. It has a different meaning. Hence, I want to use a different color pen. So this is less. If I say less, it's an operation. Yes, good. So that is more accurate now. And then we have to divide this by 2. Okay, as I just told, there are 2 sides. But in measurement, we don't use the division sign that we all know. Okay, we use what? Instead of dividing this, writing divided by 2, you are going to do what? 1 over 2. Okay, times this. And if you see this, this means what? Multiplication. Okay, this means multiplication. And less, the less means what? Less means subtraction. Okay, but 1 over something, 1 over n means division. Okay, if you want to divide by 50, if you want to divide by 50, you are going to do what? 1 over n times that number you want to divide by. And at the end of the day, life still becomes much more easier. If you like, you can use the inverse of that. That one to you realize that it's going to make life to become much more easier. So this, to divide this, you are seeing over here, it is of 2 faces. Okay, look at 495. If you say 495 divided by 2, if you have eyes, you would have seen that what? This over here, it is the same as what? 1 over 2 times what? 495. 5. At the end of the day, if you multiply this, you come and get whatever we are having at the top over here again. Okay, so they have just found a way to separate it and put it over here like this. Okay, so 1 over 2 times this at the end of the day is going to give you what? 4247. Yes, that is going to give us our answer to be 247. Let me put it over here, and this is 2 4 uh 247.50. Yes, it's rather 247.50. So let me write it all. 247.50. Okay, yes, so now we are done with our foundation spread. So at the end of the day, you know that this side, this part of the building is 24570. So this part is 247.50, and this is also 247.50. As simple as ABC. So now you have seen the spreads now. Okay, good. Let's go and also see a different way to calculate a different one too. So let's quickly move. So this can be classified as our spread. Okay. So let me classify it as the spread and let's move. So this is, let's say this now become our foundation hot spread. This now become our foundation spread. This now become our foundation spread. Okay, the 247.50. Good. After knowing our spread of the foundation, what are we supposed to do? We are supposed to add the length. Okay, we are supposed to add the length of the two sides. You see over here we have 4.00, we have 4.00. Okay, yes. Take note that for now we know the spread. We already know the spread of the hot. Uh, we know the spread of the foundation. Okay, since we know the spread, you realize that we are going to be digging a hole from here up to where? Here. Here to, we are going to dig a hole from here to here. You realize that here is 4.00, here is 2.500 meters. Okay, so that's all these sides have the spread sum. Yes, all these sides have the spread sum where the mason will stand and lay the block inside the hole. Those spreads, they contribute to much stability of even the wall itself. Okay, so um, the spread we have to calculate it for the whole length. Okay, yes, and in doing so, what do we do? We have to add a 4.00 to the total spread. Okay, that is how we can know the total length, because at the end of the day, the spread, some is going to be here, some is going to be here. But let's go and do the calculation. After that, we will come back and you'll get to understand what I'm talking about. So after that, we say we want to add. So you pay attention to some of the colors I'm using, because the colors are going to play vital roles in your understanding. Okay. Yes. So this is the less. So now we say that we want to add. So we want to add. Okay. First of all, we want to add the length first. You can choose to do it horizontal or vertically. I want to do that horizontally. So let me put my 4.00, 4.00, and the spread, okay, times 2. So 2 times what? 247.50. 247.50. At the end of the day, what are we going to get? And that is the same as our 0 0.4 0.495. Yes, 0.495, because it is the same as this answer I had over here, but just that this case, because the 4.00 is in meters, I have to change this guy also into meters so that my work can be more logical. Yes, because so that my work can be more logical. So don't get confused. So let me quickly write it. Well, this is 4.00. So at the end of the day, if you add this is going to give us 4.495 at this side. This one is also going to give us, let's say, 2.50. Okay, the other side. This is the plan. I mean this side, this 2.50 meters. Yes. Let's add a 4.95 to it. After adding the 4.95, you realize that we are going to get 2.995. After doing that, the next thing we are supposed to do would have been our description. Okay. Yes, the next thing we are supposed to do is our description, and the rest is not much of a problem again. This one, to avoid it from confusing others, I want to change a different color pen to facilitate or enhance understanding. Don't forget to throw a dollar on my name if you find this video very, very helpful and interesting. All right. So we said 2 times the spread, okay, of a single side. You're going to get all the total spread, 274.50. At the end of the day, you're going to get this and divide your answer by 1,000 to get your answer in 0.495. All right. All right. So from here, we have to just go and do our, I call it um, description. Okay, from here, we have to go and do our description. Let me clean this to avoid it from confusing others. Okay. So let's move to our SMM7, and this is our SMM7. It's a standard method of measurements. Okay. I've already spoken plenty about this, and then I believe by now you should have known how to be able to open this. If you don't know how to open this, uh, don't forget to see me in groups, in person, one-on-one. Don't forget to see me in group, in person, one-on-one, so that better still, I could throw more light on that for you to enhance your understanding. Okay, so this is our SMM7, and this is how it looks like. You can see how it looks like, and these are the rules. Okay, yes, these are the rules. The A is about preliminaries or general condition. The C is existing or building service. D is groundwork. E is in situ concrete. F is talking about the masonry. The H is talking about the cladding. A whole lot, a whole lot, a whole lot. So the one we want to do now, we are doing excavation. Excavation is groundworks. Okay, so let's go and look for it. If you come here, you can see that these are the detailed content. Okay, these are the A. You can see this is still the A. Okay, and this is the B. The B is the complete building structure or unit. C is existing site, building, or blah blah blah. And D, the one we are looking for is the groundworks. Okay, exactly. But we can find groundworks. The one we are doing now is excavation. Excavation is what? D20. You see D20. And D20, we can find it on what? We can find it at what? Page 29. Okay, we can find that D20 at page 29. So let's quickly go and open that page 29 together. and see how best life can be much more easier. So this is our page 29. Yes. So you can see groundworks. You can see over here we have written hot groundworks. Yes. So this is excavation and fillings. The first one, if you open the measurement of construction works, you open the measurement of construction work, SMM7. This table, take a look at it. All of this one up to here is the classification. Okay, going down is the classification. Yes. This is the measurement rules. This is the definition rules. This is the coverage rule, and these are the supplementary information. Don't get confused on how to open these books. Okay. The laws are the same for all observers in uniform motion relative to one another. Once you apply them, anyhow you want to apply them, once they are being applied in coherent with the book, you realize that you are never going to lose the marks. Okay, so the one where we are on now is we are on excavation of topsoil. Okay, so let's classify according to that. So the excavation is found in what? D20.2. So our excavation we are doing, look at something. You can find it in D20. That is the clause become D20 point what? 2. You see that we have found it over there. We are going to develop all the clauses very soon, and you see how life is going to be easier. So the excavation is D20.2. The 2 is the excavation because we see that the 1 is what? Site preparation, and we didn't talk about that, so we have to skip it. Yes. We didn't even list it in our takeoff. Look at our takeoff list. Takeoff list. It's not even possible. You see. So um let's proceed. So I'm just zooming the measurement of construction work so that everybody can have an equal share of the national cake. So this is it. The first one is site preparation. We don't want that. We are focused on excavation. Okay, the excavating. And if you come to the next column, this is the next column. So that is the first one. So that is now we say that we are on clause hot 20.2. Yes. So it becomes 20.2 point hot 1. So we are now on 20.2. So 20.2.1. And the point 1 says that what? Topsoil for preservation. So how are we going to do our description? We have to describe according to the SMM7. Okay, the first thing you can see over here is what? Topsoil for preservation. Okay, let's go to our specification. What did they say about the topsoil for preservation? They said that topsoil excavating to be retained on site 20 mm from excavation. Okay, that alone is enough. So let's go to our description and then we describe better. Okay, so from the SMM7, you have seen it. You said that the first one is what? Let's talk about the topsoil for preservation. If there is a reduced level, we can talk about it. If there are some pits, some numbers, or even basement or anything, we talk about it before we even come to the next column. So let's we are still on the first column. So let's see. Let's go to the takeoff list. So we write over here excavation of topsoil for preservation. Average depth of what? 150. The topsoil there, always excavation of topsoil is what? 150. You should know that. Any site, anytime I'm going to do excavation of topsoil, anytime you get a fresh site you want to build, you have to do excavation of topsoil, and that dimension is always 150. Thank you. So excavation of topsoil for preservation. Excavating of topsoil for preservation at what? Average depth at average depth of 150 mm. Okay, at an average depth of 150 mm. If you're able to do this, you realize that you are done with the description for the excavation of topsoil. Okay, but we have to come and do the squaring. Okay, so this that we have done, how do we square this? Okay, that is we have to multiply um the 4.50 times the what um we have to multiply the length times the breadth. Okay, we have to multiply the length times the breadth, or better still, after what these two things that we had, after adding the spread, you see the length of the building, you see the breadth of the building. At the end of the day, what did we do? We came to add the spread. After adding the spread, you see the figures we are getting. Okay, so if you want to write this, in the in you see this TDSD, the meaning of the T. Let me explain them over here. So we have TDSD. Okay, the T is the timesing column, the D is the what dimension column, the S is the squaring column, and this last D, this is the big box, is the description column. Okay, so in the timesing column, we are not going to write anything over there because we are not having anything to times, but we are only having some dimensions to what make use of. Okay, the area of excavation of the topsoil is measured in what meter squared. Okay, so because of that, we have to multiply just these two people. That is at the end of the that is when we are going to get the area of excavation. We have to add a spread. We have to add a spread because if you come to the plan, at the end of the day, um, they're going to dig from here to here. They're going to, you see, this corner is left over here. This corners is going to create a lot of corners. Okay, and those corners are hot at the end of the day. We ended up uh, uh, lesson. Okay, or better still to um the spread. Okay, the spread that comes with the foundation in the cross section. The spread, this spread over here is what we multiply by 2 and added to the length. Okay, to be able to get that value, and added to the length to be able to get this value. So let's say this is going to be um 4. So if you run this, you want to just write two decimal places. So if you run this 5 to this, it's going to be 0. So 4.50, 4.50. Okay, 4.50 times, let me say 2. No, if you round it, you're going to get 3.00. So 3.00. At the end of the day, you realize that you're going to get so at the end of the day, if you multiply, you come and write it in the next column. Okay, you're going to get 13.50 after multiplying. You're going to get 13.50 because we say 2 decimal places. You have to add a 0, else your answer is not going to conform to the smart standard. Okay, then when you are done, you cut 2 lines under it to show that you are done. If you don't do here, or I didn't cut 2 lines under it, so you have to cut the 2 lines under it, and that will tell the examiner that you are done. All right, so let's proceed. So the disposal of excavation material on site in spore heap average distance from excavation. That is how we have to describe that. I believe I showed you that in the SMM7 already, the excavation, and then let me say we have to talk about, they've given us the distance of the excavation, that is 20 meters away from the site. We saw that in the specification. I think this is it over here. So I believe it's not much of a problem. So after that, we will do the scoring for that too. So let's describe. So we said that what uh, disposal, disposal of excavation, or let me say disposal of excavated material. Disposal of excavated material in spore heap. Average distance from excavation of, average distance from excavation of 20 mm. Okay, all right. So I believe I'm done with this description. And then the next thing we have to move on is the what? Let me say the trench excavation. Okay, what we did is just topsoil, 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 topsoil there. You yourself, you know already. Excavation of topsoil is what we did. So uh, we have to now come to what? Excavation of trenches. Okay, we have to come to the trench excavation. That is, I think that will be in the tray. For the let me say disposal of surface water, the disposal of excavated waste. We have already spoken about it in uh this thing. We have already spoken about it in the topsoil excavation already. Okay, so that is it already for the two. So we are coming to three. We are coming to three. So the third one is our surface treatment. So I think this will be two over here. Let's come to three. The three is our trench excavation. Trench excavation. So let me put it somewhere here rather. So this is our trench excavation. All right. So for the trench excavation, first of all, we have to start from our depth. Okay, if you're talking about trench, then what is your depth? We have to know the depth. Okay, so um, this is a depth. All right. So for the depth of excavation, first of all, even if you come to the section, okay, you realize that we have hot over here. Now I can clean whatever I done on it initially since the understanding has been understood, screenshot has been taken, it has already been written. That is why I say good students should take pen and a paper so that when the teacher is teaching, they can be able to jot down important points. Once it is clean, it doesn't become a problem. Better still, you can reverse the video and write it somewhere to facilitate or enhance your understanding. All right. So yes, I'm in the cross section now. I'm in the cross section now. So, um, that means that the 650, this is where it is from here to here. The 650 you are seeing, this is where it came from. Okay. Yes. So the 650 I took, this is it. I'm also going to add a hot, the 225 to it now. So when you see, don't get confused. These are the places that they are from. Yes. So let's move to our worksheet. Um, so 675. They are all in Please remember, multiplying by our hot, or we add. Okay, we are adding rather. So 225. We are going to add the two of them. At the end of the day, you realize we are going to get 900. So if that is the case, it implies I'm supposed to write add over here. So this becomes add. Okay. But there was one thing left over here. The disposal of excavated material in spoil heap is calculated in volume. We didn't do this thing for it. Okay. We have to square the dimension for that one too. Okay. We have to square the dimension for that one too. Since disposal of excavated material, we spoke about it. This is it over here. Um, we spoke about it in the takeoff sheet. So then if I draw a line over here, I can put it over here as let me say this can be our two, and then the two is let me say disposal of excavated waste, so that you don't get confused too much. Um, so this becomes the disposal of excavated waste. So it's done in volume. So we just have to do the calculation over here and then we are good to go. Okay. So I want to do that in a different color pen. All right. So first of all, we have to take our hot. These answers as usual, the 4.495 multiply it by the 2.995 that is now known as 3.00 after running. Then you use that to multiply the hot thickness because the volume is equal to what? The length times the breadth times the depth. Okay. So what was the volume, or let me say, what was the depth of excavation? It was just 150. If the depth of excavation is 150, then it means that we have to multiply the hot 4.495 Let me put that well. 4.50 times 3.00 times 0.15. At the end of the day, if you multiply all these three quantities, what are you going to get? You're going to get 2.03. So you see, this becomes your final volume of what? Uh, Excavation of topsoil. Okay, yes, the total topsoil, and this is in meter cube. Oh. This one I've just written is in meter because you can see that I multiplied three things. Okay, and they are all in meters, 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 meters. So you don't get confused. Don't get confused. All right. So we were here. So the trench, we said the depth of the trench. First of all, we went to take the let's say the 675, and now we came to take the 225. We added, we had 900. After getting the 900, what are we supposed to do? We are supposed to less the topsoil. Okay, so let's see how to go about that. I'm supposed to less topsoil. Someone is asking which topsoil. Okay, I'll be showing you very soon. So we say that let's less the topsoil. Less topsoil. Less topsoil. And lessing of the topsoil. Um so they say we should less the topsoil. And that is 0, or it is 150. Since this one is in mm, let's put the other one also in mm. Okay, so that becomes the 150. So at the end of the day, if you cut here, what are you going to get? Finally, we are going to get um we're going to get our answer to be, we're going to get our answer to be 750. 750. Yes, 750. So this 750 now becomes our hot, our depth of excavation. That 750 now become our depth of excavation. Yeah, I feel I've not written something well. Let me quickly come and rewrite it well, and then we'll see how best can be able to travel. All right. So now we have to come and do calculation of the length. Okay. Let's come and calculate the length. So now you know the depth of the excavation. That is, if I come to the section, that is just um from here to here. You now know the number it sum up to. That is, let's say, 675 plus 225. That is giving us 900. And if you less the, let me say, excavation of topsoil, if you less the topsoil, you're going to get your 750. Okay. Yes, you're going to get your 750. Exactly. So let's proceed to the length. How do we go about the length? Okay. Let's see how best we can be able to practice that. So our length, let me calculate the length over here. So the length now, first of all, we know that we had 4.00, and we also have, uh, because the reason why we are calculating length, we already know the depth. Now we are calculating the length is that excavation. Excavation, you know that excavation is uh, measured in what? Length times breadth times what depth. So after we know the depth, we have to also know the length. Okay. Then for the breadth, we already know it. This is the breadth over here, 750. If we come to the plan, or let me say the cross section, you see it over here. This is the what? This is the breadth over here. So that one is already know. Now we also know that the depth is 750. So we only have to find the length, then we less the corners, then we are good to go, right? Okay. So 4.00 plus 2.50. And what is that going to give us? We are going to get 6.50. So over here, we are adding. Okay. If you still go and multiply this thing by 2 because we have two sides, it's like they are calculating for the whole length of the building. No, my people, it's just like we are calculating for perimeter. Don't get confused. 4.00 plus 4.00 plus 2.500 plus another 2.500. You will get the same answer we are getting. Okay. But just that we are doing this one in a different way. I told you if you see this last time, it means multiplication. And this we are adding. So we say that add. All right. So at the end of the day, if you multiply this by this, you're going to get 13. 13.00. And that becomes our length, including the spreads. Okay. And also, no, there's rather our length, including the corners. Okay. So we have to less the corners. Okay. In that case, we have to less the corners too. So watch. The thickness of the block. The thickness of the block is 225. Okay. But before that, let's less the corners before, and then we see how best to travel. So let's less the corners. Let me quickly change the name of this. I want the work to be more dynamic. So this, now I can write the depth proper. This is the depth. Then let's say let's less corner. since we are ahead to the use of some colors, we have to follow that. So we say that now we want to less corners. Okay. So we want to less corners from whatever calculation we are doing. So the lesson of the corners, first of all, what do we have to do? We have to multiply, or better still, um, all right. So the cavity wall you are seeing over here, it is having a thickness of, let me say, 255. Okay. It is having a thickness of, let's say, 255. And then um, the 255 cavity wall we are seeing over there, um, we have to multiply it by 4. Okay. So this is what I'm doing over here. Let's say 4 times 255. Because if that is the thickness of the block wall, if that is the thickness of the wall, if this is the thickness of the wall, it means that it is at all the corners. So it is at all the corners. So we have to less it. Okay. So that is going to give us um that is going to give us let's say 4 times 255. At the end of the day, we are going to get our answer to be 10. 4 times 255, 1020. But if you divide it by 1000, you are going to get 1.1.02. You're going to get 1.02, and 1.02 at the end of the day, if you subtract it from this 13.00, you are going to get 11.98. You're going to get 11.98. So the rest is just left with a matter of description. Then we do a few bit of squaring. Then that will be all. So let's come and do our description quickly. If you have the SMM7 beside you, you can take it. Okay. Okay. So we have to open to excavations. We have to open to excavations. So let's go to the SMM7. So the excavation, as we are saying, is already here. You find it in D20, page 29, and once you're able to open it, that is it, page 29. So on page 29, now we are doing proper excavation. Okay, so excavation trench width, excavation trench width greater than. Let's go to the specification. Foundation concrete. Okay, let's come and see our cross section. We have seen the width now too. We see how big the width is. So in our SMM7, we know how to behave now. So the depth of the excavation. Uh, our excavation trench width should be greater than 0.30 mm. That is maximum depth should be greater than or equal to 1.00. Yes, if you agree with me, what I'm talking about, this is what I spoke about. This is what I spoke about. And also, the depth they gave us. You realize that um, we had, let me say, the width of the trench. Okay, the width of the trench. Um, we have, let's say, 0. Um, or let me say our width. It has even been described over here. Okay, so we have to take this one. Okay, so we have to even speak about the width before we come to the maximum. Okay, so let's take it this way. We are going to say that excavating trench width, because the kind of excavation we are doing is trench. Okay, and it's the width we want to be specific about. So excavating trench width greater than 0.30 meters. Okay, greater than 0.30 meters. Okay, but less or equal to, or let me say, uh, yes, but greater than or equal to 1.00 meter. Okay, yes, but less than or equal to 1.00 meter. That is the depth. Okay, that is less than or equal to 1.00 meter. So let's go and write it and see how. So that is, we are going to say excavating excavating trench excavating trench with greater than 0.30 meters and maximum depth less or equal to 1.00 meters. All right. So we have to do what? Adding on. It means they all have the same measurement. Okay. Whatever measurement I'm going to do, it means they all have the same measurement. So since there is not enough space, it means I have to continue it from here. So it proceeds. Then we say filling to excavation thickness. Filling to excavation average thickness. Greater than 0.25 arising from excavation. Then the last but not the least, we have to do comparison bottom of excavation too. Okay. So we're also going to do last but not the least. We are going to compact the bottom of the foundation. So that is the compacting bottom of foundation. They are all part of the earthwork supports. So compacting bottom of foundation of foundation. Okay. So we can do the squaring now. Okay, so the squaring, look at the first one. 11 times what? 13. No, yes. Is the 30. The 30 is not, it is this one rather that is the total because we left the corner from it. So 11 times 9.8 times the depth times the what? Breadth. And that is all how you get your volume, okay, of excavation. So let's do that over here. And that becomes so let's say this is 11.98 times the depth, length times breadth, 2 times the breadth. So 0.75 times the depth, 0.75 again. When we calculated for the depth over here, what did we get? We had 750. 750 divided by 1000, you get 0.75. Okay, that is what we are writing over there. And you remember that I told you that um the section, okay, the section, this is the breadth or the width, whatever. So that is why I'm also writing 750 over there. So don't get confused. The laws of measurement are the same for all observers in uniform motion relative to one another. All right. So after multiplying this 11, 11.98 times 0.75 times 0.75, we're going to get 6.74. So that becomes the 6.74. Okay. Then after that, what do we have to do next? We have to do the same thing for the comparison of foundation. Okay, the comparison is done in area. So the length times breadth. I told you that the breadth is 750. That is the width of the foundation. Okay. So at the end of it, we just have to multiply the length. And the length is 11.98 times the breadth. That is 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. 0.75. So I'm going to get 8.99 over here. Okay. So we are left with earthwork support, then concrete and foundation. Small, we are going. Okay. So the earthwork support. The earthwork support. Let's look at the earthwork support and then. So the earthwork support is the same as the surface treatment. So to avoid confusing you, let me say, so we are now on the surface treatment. We are now on the what? Surface treatment. That is um so I think that is going to become our four. Okay, that is going to become our four. So okay, I didn't add excavation of trench to our takeoff sheet. Okay, so let me just add it quickly and then let's proceed to make our work to be more coherent or to make the work to be more detailed. So let me quickly add that and then let's proceed. So we said this is our surface treatment. We even have to do trench excavation before that comes. So that has this is trench excavation. So trench excavation, foundation bottom. Then now I can bring my no. Now I can bring my, let's say, now I can bring my surface treatment. Yes. So this is now going to be the surface treatment. So this is 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. So our fourth one rather is what you're supposed to be looking at. Surface treatment or earthwork support. Okay. Surface treatment or earthwork support. So the fourth one, earthwork support. or let me put it the other way around. We say surface treatment or earthwork support. Okay. So the surface treatment or earthwork support, we can now start. Okay. After calculating for the total length, adding the spread, how did we get? We had 4.4955, right? So let's play with those values. So in that case, since the earthwork support is 2, since the earthwork support is 2, it means that our length of excavation was, let's say, 4.4 955. We also have the other one to be 2.995. We did this calculation. We had these answers parameters from here. No one should get confused. We had these parameters from here. These are them over here. These are them over here, right? Is this not them over here? So no one should get confused. Okay. So now we have to multiply them by 2. Yes. Since there are 2 sides, the earthwork support, we'll be doing it for both sides. We can't do it for one side and leave one side alone. Yes. So after doing that, this is going to give us 8.990. Then this is going to give us 5.990. At the end of the day, if you add both of them, if you add both of them, so here we say we add. So let me input the symbol and the rule. So we are adding. So at the end of the day, after adding, we are going to get 14.980. 14.980. Good. And that is the outer surface. So that becomes the outer surface. So let's just say this is the outer surface. Or let me say the outer face. What about the inner face too? Okay, so from here we have to less. Okay, from here we have to less. We have to let four. We have to less 4 times because of the internal trench. Okay, we have to less 4 times 2 times the what depth of excavation. Yes. So let's say the 4 times, sorry, 4 times 2 times 0.75. At the end of the day, you are going to get 6.00. So if you less this 6.00 from the answer you're having over the top, you're going to get 8.98. Okay. And that becomes your internal trench. So this now becomes your internal trench. So this now becomes your internal trench. Because after lessening the hot, let me say the breadth or width, okay, because at the end of the day it's at all sides, okay, it's at both sides, but at the end of the day the corners are hot, the corners are 4, okay, the corners are 4. Yes. So at the end of the day the width is at 4 sides, so the width is at 2 sides of the length. Okay, so at the end of the day, the corners are also 4. So 4 times 2 times the width, we get 6.00. If you subtract it from that, you're going to get the internal trench to be what? That. So this is the internal trench. So this is the internal trench. So that is the internal trench. The only thing we have to do now is we have to do something we call uh, description. We have to do description. So in our description, we say that we have to go to the SMM7, okay, and go to earthwork supports. Earthwork support. Okay. But before that, if anyone has any question to ask, he or she could just type that into the comment sections. Better still, you can meet me in groups, one-on-one and in person or in person, and then I'll find the best solution uh, to your problem for you. This course is a practical course. This course is a practical course, and failure to practice some of these things can end you up in a very big problem. Okay, so despite you are being taught, you are being helped with learning materials, but I wish you can learn extraordinarily harder. Okay, you should sit harder so that life can become much better than it has always been. Yeah, so that life can become much more better than it has always been. So let's proceed. So you have to open our SMM7, and then this case is a different thing we are going to do, and that is earthwork support. It's still under the groundworks. Okay, it's still under the groundworks. Look at it over here. It's still under the groundworks. The groundworks, earthwork support is under the groundworks. Okay, yeah, so don't get confused. If you open your SMM7, you see it. So we just have to do the description with the book, and life become much more easier. In the first column, what can you see? This is the first column. This is the second. It continues. So this is earthwork support. We have seen it. So the first one, we have to say that what? Maximum depth should be less or equal to what? 1 meter. Yes. And also the distance between opposing face. This is it over here. Distance between opposing face should be less or equal to 1 meter. So we're going to describe this with respect to this and also describe it with respect to this. Okay, good. Because they didn't talk about curve below or ground level or anything, we leave it. Do you understand me? Yes, yes. So earthwork support is measured in what? Meter square. That is what they have put over here. That is, they are trying to tell you that it's measured in area. Once you have been given, that is why I said that you have to learn how to use the SMM7. To be able to be a good quantity surveyor, you need the SMM7. All right. So let's say the earthwork support. Earthwork support or surface treatment maximum um, depth should be greater than or equal to 1.00, just as I told you. And in the next column, we are saying that what? The distance between the distance between the opposing face is less or equal to 2.00 meters. Okay, yes. So we are done with the fourth one, that is the earthwork support. The next thing we will have to do now is probably we have to move to the fifth one, which is a foundation or concrete and foundation. Okay, I told you concrete is measured in meter cube. So, but before that, we have to square the dimension for earthwork support. So in squaring of the dimension, 14.98. Let's quickly do that together. 14.98. So this is 14.98 times 0.90. Don't get confused. After running this value, that is what we had. Yes. After running that value, or better still, the volume of excavation, or let me say, uh, hello. All right. So the earthwork support, okay, we said that it's measured in area, just as you saw in the SMM7. This is it over here. That is why I'm just doing it for what? 2 units. That's why I'm considering 2 units over here. This is in meters. This is also in meters. Okay. If they're in mm over, you have to come and convert them in meters before you can write it. Good. So the 14.98, I'm multiplying it by the what? Come and see the cross section times the depth of excavation, the overall depth. Look at what I'm seeing over here. If you add, because at the end of the day, the topsoil, when we excavated, we did surface treatment too. So for all that place, we're going to do surface treatment from here to where? Here. So just imagine. But even before that, the surface treatment that we are going to be doing is going to mainly cover from here to where? Here. Okay. So that is the 675. 675 plus the 225. What are you going to get? You're going to get 900. Okay, so that is why we wrote 900 over there. So that is 900 divided by 1000. And you're going to get what? 0.90, as you are seeing over here. 0.75 is just the width. Okay, 0.89 times the width. Okay, so this is the outer face times that. And then the width. The width is, or let me say, 8 point. For the internal trench, we are seeing what? 8.98 times the depth, and the depth is 0.75. Okay, the depth is 0.75. So at the end of the day, that is how the calculation went. Okay, so the 8.98 times the depth, and at the end of the day, the depth of the excavation. Then when we calculated for the depth of the excavation, what did we get? We had a 750 you are seeing over here. Okay, so that is it. They divided by 1000 to get uh, um, the answer you are seeing over there. Okay, so let's quickly square quick, and let's provide the answer, and let's go. Okay, we are far behind time. So this is going to give us the first one, 13.48. And then the other one is going to give us 6.74. So at the end of the day, we are going to get 20. Point 22. So let's proceed. So now we are done with the earthwork support. So we have to move to concrete and foundation. We are almost done. We are almost done. We have to move to the concrete and the foundation. So that become our fifth takeoff we are supposed to look at. Let me see. So that disposal of surface water. Okay, that one is just water. So we are going to 6. That is concrete and foundation. So 6. 5 is disposal of surface water. So let's look at the 6. So concrete and foundation. So for the concrete in foundation, from the specification, they say concrete in foundation to be institute concrete, blah, 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 a whole lot they said over here. Okay, so um we have to note that. Then we just come and calculate for the concrete quick, quick, quick. We're going to do our block work, then we are good to go. So um so this become our in situ concrete. If we say in situ means it was done on site. So the in situ concrete, so the in situ concrete foundation design mix is what? C25, C25, 20 mm aggregate maximum, 20 mm aggregate minimum, cement minimum cement content. Okay, so minimum cement content, minimum cement content of 290 kg per meter cube. Poured on or against. Okay, so poured on or against. Poured on or against and what? Deduct D D T filling to excavation ABD. That is, we have to add So here we have disposal of excavated offsite. Disposal of excavated offsite. All right. So um maybe we just have to come and do our squaring and see how best we can be able to proceed. So I'm almost done. And concrete and foundation. Um, so the concrete and foundation. We say concrete is measured in volume. Okay, so if it's measured in volume, let's quickly do the calculation for it, and then so we know that 11.98 is the length of our building. Okay, we calculated for it over here. 11.98. This is it over here. We have over here 11.9. If you can see the mouse moving over, so 11.98. 11.98 times the breadth. Okay, 0.2, no, 0.75. The breadth, everybody knows. Times the thickness of the concrete bed itself. It is 225. If you divide it by 1,000, you get um 0.23. This is it over here. If you can see the one I just, if you can see the one I just circled. Okay, so the 225 is the thickness of the concrete. So we say concrete is measured in volume. The another say length times breadth times height. Okay, the length of the building is 11.98, and then the breadth is 750 times the 225. You see, so that is why I keep saying the laws are the same for all observers in uniform motion relative to one another. So times 0.23. At the end of the day, what are we going to get? So let's do that together. 11.98 times 0.75 times 0.23. We're going to get 0.07. So this is going to give us 0. No, this is going to give us 2.07. So let me write it well. 2.07. So I cut under it twice, and we are good to go. Let's take the block work. Then we'll be left with, the last thing we are done, we are left with to do is just the block work, and then we are good to go. Okay, so let's take the block work. So we are done with concrete and foundation. Okay, so the next thing I'm supposed to do is the 7 block work before we even come and do hardcore filling, surface treatment for the floor, the formwork, and also the finite oversight concrete. Okay, so let's go to the block work, which is number 7. Number 7 for the block work. So this is the 7. So 7 is block work. Okay, so the 7 is our block work. The block work. For the block work, we have to start from the height. Okay, so um, the height of the block wall. We have to start from the height, and this is a height above ground. Okay, so let's start from the height. Let's state it as so the height of the block wall. See something, this is the height. You see the height of the block wall is 675. So 675. If we subtract the concrete bed, it is just from here up to here. From here is this one. You see, so that is the 675. Let me clean all these pictures. I don't know. It is rather confusing the work. So if I'm talking about the height, this is it. The height of the block wall. Yes. So let's proceed. Times 1. That's the thickness. Yes. So 150. The thickness of the block wall. 150. And at the end of the day, if you add this, you are going to get 825. Okay. So the 150 is the what? Excavation that they did. Okay. The excavation that they did. So the 675 is the height of the block wall. Height of the block wall uh, plus the 150. So you see, so the 675 plus this 150 over here. You see, the thickness, which the thickness of the topsoil excavation, which is giving us what? The answer we are getting over there. That is the 825. Okay, that is the height of the block wall. So I believe you know how we calculated for it. So let's go and do the calculation for the center line of outer skin. So center line of outer skin, center line of outer skin. It's left with one last one. So this is the center line for outer skin. Center line of outer. Center line of outer skin. Okay, so that one, let's do it quick, and let's wrap up. So this is 2 times 4.00. You know where it's coming from. If you take the plan per, you see it over there. 4.002.50. So you see, times also these two, because there are two sides. That is why I'm multiplying it by 2. 2.50. At the end of the day, we are going to get a perimeter. So this is going to give us 8.00 This one is also going to give us 5.00, just as usual. So at the end of the day, we are going to get 13.00, 13.00. Okay, but we have to less the corners. We have to less the corners. Take note. Have you seen this value over here? Let me use something else to highlight it. I just highlight something yellow. What I just highlight yellow, take it serious. So what I highlight 0 is, let's say 102.50. Okay, at the end of the day, we are going to divide it by 2 and tell me the answer. You divide it by 2, you are going to get 52.25. 50, it's supposed to be 51.25 father. So that is 51.25. Good. So that is Blockwork 102.50 thick brick wall in cavity construction. So that is it. Okay, so keep this value somewhere. I'm going to talk about it shortly. So this is the value we had. That is, we know this is the perimeter of our outer hot skin. So if we want to less the corners, let's less the corners. Because of the language we are speaking, I have to change marker and less corners. Now I can change my marker to initial. So let's less the hot corners. So in lesson of the corners, we have what? Now you have seen the actual thickness. So we have 4 because we have 2 sides of the building. Let me say at the end of the day, we have 4 corners. Okay, 4. We have internal and external plan. But because there are 2 sides times 2, okay, yes, times the 51 point, this thing that I told you about, 51.25 that I told you about. Yes, over here, that is in our plan rather, or specific, yes. So this answer I told you to write somewhere, this is what we are using over there. And then at the end of the day, we are going to get 0.41. But take note that this value, we don't want to use the raw one like this, okay? This is in millimeters, okay? It's in millimeters. Because we go to the specification, you'll see it's in millimeters. So if you divide it by 1,000, you are going to get your answer to be 0.051. Yes, 0.051. And I think that is far better. 0.051. Okay. So finally, we are going to be getting 0.41. 0.41. So we can say that after our subtraction, I'm going to get, let's say, 12.59. 12.59. Okay. So that is it. So let's also do for the inner. So now we know the external, okay? We know the center line for outer skin. Let's also look for center line for inner skin too. Then we can wrap up for the day. We are almost done. We are almost done. So we are looking at the center line on inner. center line on inner skin. So it's the overall length we know is what 11.98 of the building plan I sent you. 11.98. 11.98. Now we have to less some one or two things from it. Okay, yes. So let's less 4 times 2 times 76.25. Yes. So you see that less means subtract. So less 4 times 2 times let's say 76.25. 76.25. You're going to get 0.61. And at the end of the day, if you less, you're going to get 11.37. Yes, so I can cut here twice. And then at the end of the day, I can just describe. Okay, since I don't have enough space here, maybe I'll have to come and do it at this side of the takeoff sheet. But before that, let's quickly square the dimension for all our calculations so that life can be more easier. So let's quickly proceed. Okay, so our 12.59 we had 12.59, and we had that after lessening the corners from the perimeter. So this is 12.59 times 0.83 0.83 times is for the distance. Don't get confused. Okay, 825 divided by 1,000. That brought about that answer. You know where we had the 825. Yes, so that is why they came and ran it and they get 0.83. It is this answer. This guy, the block work, the height of the block work. They divided it by 1,000 and they wrote 2 decimal places over. You don't get confused. Okay, and 11.37. Here is 11.37. 11 point, because 11 point block work, we told you that it's measured in area. So that's why we're measuring this one in areas too. So 11.37 times 0.83. So at the end of the day, you see what we are getting. We are going to get 10.45. And here we are going to get 9.44. So at the end of the day, if you add all, you should be getting 19.89. Yes. All right. So let's just quickly describe quick, and then let's go. Okay, let's go. So um the description, with the description, it's as simple as that. So we say that block wall thickness, because it's already in the specification. This is it. Block wall thickness, 0.0102.50 thick. Truss bond in 1:3. Okay, this is it. So stretcher bond of 1:3. So we just, the specification has already been given, so we can use that to describe it. And then life is now much more easier. So we can say that block wall thickness, 102.5 mm in stretcher bond. In stretcher bond of 1 in stretcher bond of cement and sand. So in stretcher bond is what? 1:3. So basically, I think this has brought us to the basics of measurement of construction works. Practice them, as practice is one of the things that can make you to become more perfect. Yes, so you really have to practice it. Failure to practice some of these things will cause you to be risking your own life. Okay, so I wish you practice this more often, so that at least you can become more learned even before the paper or the time of start of the exams. Once again, I wish you all the best. Thanks for accepting this initiative. Keep the contributions coming, as the data is one of the things that is able to motivate me to be able to do the work. Without data, you realize that life is going to be very, very, very much difficult. Don't forget to throw $1 on my name if you also find this video to be very, very helpful. Yes, if you find this video to be very, very helpful, don't forget to throw $1 on my name. May God richly bless you all once again. Thank you very much. Bye bye.